Hey everyone, Snowflake is extremely powerful and extremely popular, and they have some really good reasons for that. In this video, I'm going to share with you 10 powerful Snowflake SQL features that are some of the reasons on why Snowflake kind of stands out compared to any other traditional databases. Let's start with the first one. Qualify. Now, qualify is a special keyword or a clause in Snowflake which you can use to filter the data that is returned from a window function. Now, in order to better understand that, let's take an example of this payments table that I have already created. So it has four fields. There is a payment ID, customer ID, payment date, and amount. Let's say you have been given this business problem statement where you are asked to fetch the two recent payments done by each customer. Now, generally, when you have this kind of a requirement, what you would generally do is you would use a rank window function. I have written this query already here to save some time. Okay, now what am I doing? I am using rank. I am partitioning the data for each customer, and then I'm sorting the data based on the payment date in ascending order. Okay, now what this will do is for each customer, it's going to basically create ranks based on their payment date, right? Now, if I run this, you can see that this RNK field has been created, right? Now, ideally what I want is, because wherever the rank is 1, that is basically the last payment date, the latest payment date, right? So since I want two recent payment dates, I just need to fetch wherever the data is rank 1 and 2, right? Now, ideally what you would think is you could probably filter the data saying that where RNK is less than or equal to 2, and this should ideally give you your output, right? But as you can see, it's going to throw you an error here. Why? Because in SQL, you cannot directly filter the result from the value that you're getting from a window function. Okay, so this basically does not work. Now, how you would generally do this in any other database is by moving this whole thing into a subquery. So what I can do is I can say select star from and open the parenthesis here, move this to the right, close the parenthesis, and now run this and it will work. But the problem here is that this is not a very efficient query. Why? Because you are unnecessarily creating a subquery, right? But in Snowflake, you don't need to create a subquery. There is a better way of doing this filter, and that is by using the qualify keyword. So I'll just paste the same query here, and previously when we gave where RNK is less than or equal to 2, it throw an error, right? What we need to do is instead of filtering based on where, we just need to use the qualify keyword. Okay, so mention qualify and then everything else stays the same. You can see that now it works. So what's happening is qualify can be used to filter the results that you have got from your window function. Okay, so this is very useful when you are using window function and you want to do certain filtering. Okay, it will avoid creating unnecessary subqueries. Do you know, I have just created a brand new SQL learning platform called SQLNest. I have created it from scratch and I've made sure that it's going to be the only platform that you'll ever need to learn SQL. Whether you want to solve interview problems or you want to solve some real world SQL business scenarios or you want some fun ways to test your SQL knowledge, you will find everything in SQLNest. Plus, in addition to that, you will find some amazing recorded SQL courses. But this is just not any other recorded SQL courses. These are hybrid courses. And why do I say hybrid is because when you go through these courses, let's say you got stuck, you have some questions, you can directly ask these questions or clarify your doubts with the instructor, that is me. And me as the instructor, I'm going to either make some separate videos to answer your questions and clarify your doubts, or I'll be conducting regular live sessions where I'll take up all of your questions and try to answer them. Okay, now this is a feature that in my opinion does not exist in any other platform. So definitely make use of that. The beta launch of SQLNest is happening on Sunday, 16th of November, and the full launch happens 1 month later. You'll find all the details in the video description. If you're watching this video after 16th, you'll find the link to the platform on the video description. So definitely check SQLNest. Let's move on to the next feature now. Now let's move on to the second feature, which is sample. Now sample is a keyword in Snowflake that will let you randomly generate some sample data set from your given table. This is very useful when you have like a large data set, let's say thousands or millions of records, and you want a small subset of that for certain analysis or for audit purpose, or you want to train a model, etc. Now, in order to better understand this, I have this orders table with some 10 records. There's an order ID, customer name, order date, and amount. And you have a business problem statement here, which basically tells fraud detection team would like you to randomly fetch around 5 orders for their manual review. Okay. Now, what you can do here is you can just put this sample keyword and then inside the parenthesis, just put a number. Okay. Let's say I'll put 50. Okay. Now, what this 50 basically means is this is like 50%. Okay. So it is going to fetch you 50% of the data from this table, but it's going to randomly fetch you that data. Now, if I just run this, you can see that this table has 10 records. So 50% of that, ideally you would expect it to return 5 records, right? And that's what you're getting. But now let me execute it again. And you're getting 5 records. I executed again. Now I'm getting 8 records. I executed again. Now 8 records. One more time, 5 records. The next time, 3 records. The next time, 6 records. The next time, 5, 6, 7, 6. So what exactly is happening? I told you that it's going to return 50% of the number of records, but that's not exactly what's happening, right? The reason for that is this 50% is not on the entire result set. It's basically based on probability, but it is based on each record. So what this means is there is a 50% chance that this record will get returned during the execution of this query. Okay, and the same thing goes to the second record. There is a 50% chance that this second record will show up during the execution of this query. So this 50% of probability is not based on all the records at once, but it is basically the probability for each record. Okay, so that is why sometimes a record might appear, sometimes a record might not appear. So the total number of records returned using this sample might not always be fixed. Okay, now this is like when you want an approximate percentage of number of records to be returned, you can use this. But let's say you want a fixed number of records returned. So I always want 5 randomly generated records to be returned. Then what I can do is I can say 5 and then I can use the keyword rows. Now if I run this, it's always going to fetch me 5 records. But you see that every execution, the data could change. It's because it's randomly fetching the data. Now this will make sure that it is fetching 5 rows. If you don't mention these rows, it means it is percentage. Now let's move on to the third feature, which is UNPIVOT. And I think by the name, you would probably know what this means, right? Now this is basically kind of like the opposite of pivot, which is present in most of the databases. So UNPIVOT is useful when you want to transform your column level data into row level data. Let's say you have this business problem where you have a table that has sales data for each month in separate columns. So when you have these kind of data, analysis becomes difficult. So if I just query the table here, monthly sales, you can see that I have the product ID, product name, the sales for Jan, the sales for Feb, and the sales for March, right? So the sales data is scattered across multiple columns. So this is not good for doing some analysis, right? Now what we want to do is we want to transform these 3 columns into one single column. So you need to have one column for month and its values should be in another column, let's say sales, okay? So in order to do this kind of transformation, we can use UNPIVOT. So what we can say is, first of all, let us fetch the columns that we need. We need the product ID, we need the product name, I need a month column, and I need the sales column, right? And it's going to be from the monthly sales table. And here we just use the UNPIVOT keyword and then mention certain details. Okay, so we want to do the UNPIVOT on these 3 columns, right? But these values needs to be returned, right, into that one particular column. So what we do is we say sales, okay, for month in, we mention the 3 columns that we basically want to transform, right? The first column is the Jan underscore sales. The next column is the Feb underscore sales. And then the last one is the March underscore sales, right? And I think that's all. If I just run this, you can now see that I'm getting 15 records in total because for each of the product, it basically created 3 rows, okay? One row for Jan, the second one for Feb, and the third one for March. And the sales amount is shown here. Now let's move on to the fourth feature, which is pivot. Now, you know probably what pivot is. It's kind of opposite of unpivot. So if you want to transform your row level data into column level data, that is where you use pivot. This is kind of supported in most of the databases, not all of them, but most of them. Okay. But it's pretty easy to use in Snowflake. So let's see how to use that. Now I have this table sales data, which has information about different products, the product name, and certain month information and the sales that have happened in each of the month. I want to transform it into like a separate column for each month. How I am going to do that is I'll just copy this whole thing. I'll just put it here and I'll just use my pivot keyword. And here I'm just going to say almost similar syntax to unpivot. So here I'll do the aggregation because it could happen that for a particular product there could be multiple records for a month, right? Then I'm just going to do an aggregation here. So I'll say sum of sales for month in basically these 3 months, Jan, Feb and March, right? But we need to provide that value. So I'll say Jan, and I want a column name that will be returned to be called as, let's say, Jan underscore sales. And I'll just copy this whole thing because I need to repeat it 3 times. So this is for Feb, and I'll call this like Feb. And finally, this is for March, and I'll call this March. And I think that's it. So if I just run this, now you can see that my row level data has been transformed into column level data. So you have one new column for Jan, second one for Feb, and third one for March. Now let's look at the 5th feature, which is clone, also referred to as zero copy clone. What this basically means is, in your traditional databases, whenever you want to take a backup of a database or a schema or a table itself, you basically kind of create the copy of that table, right? So meaning you kind of create the same storage multiple times, right? So you are incurring the additional storage cost for every copy that you create. When it comes to Snowflake, you can use the concept of clone. What this basically does is it's going to create a clone of an object from the original object, but it does not replicate the storage. Meaning, if I create a cloned database, both the cloned database and the original database from where I actually cloned it, they both will be sharing the same storage. So whenever you clone an object, whether it's a database, schema, table, or few other objects, you are basically sharing the storage with the original object. So there is no additional cost on storage. Secondly, because you're not kind of replicating the data, you're not creating duplicate data in the storage, this whole clone process is super fast. Okay. So, and there are other advantages as well. Now, just to better understand this concept more clearly and its usefulness, let's take a scenario. Let's say that we have a production database called SQLNest underscore prod. Okay. And there's a table called sales order in that database, as you can see here. And you can see that in the last 2 days, the orders that came in, the amounts are pretty low. We realized that these amounts, there were some issue with the data that we got. Ideally, they should be multiplied by 1,000 for the correct amount. Okay. Now, but we are not sure if that fix will actually solve the issue, right? So we want to do some experiment, some testing, analysis, and then only we want to make sure that this fix is present in a production. So what we do is we can kind of create a clone of this entire database. We do the fix in the cloned database. We test it, we verify it, and if everything looks good, then we can move that change into the production database. Okay. So currently I am in the SQLNest underscore prod database. First of all, what I'll do is I'll create a cloned database. So I'll say create database SQLNest underscore test. I'm going to clone it from SQLNest underscore prod. Okay, so I'll run it. It's going to create a clone database by the name SQLNest underscore test. Next, what I'm going to do is I want to use this database. So I will say use this one. So I am currently pointing to the test database. Now I want to do the fix to this table here. So for that, what I'll do is I will say create or replace this table. Now this is a very simple example, bear with me. And here what I want to do is I will mention all of my columns. So let's see what columns this table has. So I have the order, ID, I have the customer name, I have the order date, and then I have the amount. This amount is the field that we want to fix, right? Now, what we want to do is, we know the issue has happened in the last 2 days. So we can say that case when took care of this particular field, that is order date, okay? And let's say when it is Wi-Fi DD is in these 2 dates, right? So that is 5th of November and then 6th of November. Whenever the order happened on these 2 dates, then I want to change the amount, basically multiply it by 1,000 to fix this issue, okay? And else I want it to be the same amount, right? And this column will be called as amount itself, okay? So I'm assuming this should fix the issue, but let me do this and let me run this query. You can see that now I'm getting the proper amount. So that small decimal values are now replaced with these proper values. So this is the fix. Let's assume that this is the fix that we needed, okay? And what I'm going to do is I'm recreating this sales order table with this fix, okay? So create or replace, I missed the keyword table here. And now let me run this. And now this table is recreated. So if I just run this table, okay, sales order, just to make sure that I'm in the correct database, I'm just going to mention the database name and also the schema name, and then I will run it to see that, okay, now I have the correct data. And now let's say internally you might want to do some other testing from the UI, you do verification, the QA will do the testing and everything, okay? And they say that, yes, this change has fixed the issue, okay? Now you know that this change has fixed the issue, you want to move this updated data back to the production, right? But if I look at my production table, that database is prod. In the prod, I still see the old data, right? So what I'm going to do is I'm going to recreate the table in prod using the table from my cloned database. So I'm just going to say create or replace table. This one, I'll say clone it from the test database, same table. Okay, because I know in my test database this table is correct, and in my prod database this table is having some issues. So I'm cloning the production database table from my cloned database table. Okay, this is done. Now if I go into my production table and run it, I can see that I have the correct data. Okay, now this is basically how the cloning of database, cloning of tables was very useful here. This is a very simple example, but I hope you get the understanding of what clone is and why it is useful. The next feature that we are going to look at is time travel. Now this is one of my favorite features simply because it kind of gives you the peace of mind that if something goes wrong, you can always get it back. What time travel basically means is that you can get historical data. You can basically get access to the historical data in tables, schema, or your databases. Now I'm going to explain this with an example. So I have this orders table which has 10 different records, so 10 orders here. I'm going to make some changes to this table, okay? And then I'm going to show you how you can retrieve back to the original data, okay, using time travel. Now, first and foremost, let us look at the current timestamp, okay, so that I just know the timestamp when I had the original data. So that is this one. So I'm just going to record it here. Now I'm going to make some changes to the table. So let me first update the orders table. I'll say update orders, set amount equal to 0, where the order ID equal to 101. Okay, so this should update the first record, the first order. Then I'm also going to delete the last 5 records. So I'll say delete from orders table where order ID is greater than 105. So this should delete the last 5 orders. Now if I query the orders table, you can see that I only have 5 orders, and the first order, the amount is 0, right? So the data has been changed. Now what I'm going to do is I'll wait for a minute. I'll just cut that. So I'll wait for a minute and I'll come back after a minute or two and I'll show you how we can access the historical data. Okay, so I have simply waited for 2 minutes. Now let's see the orders table. You can see we have this updated data, right? I want to go back to the original data. So for that, what I can do is I'll just take this query, I'll put it here. And you just say select star from your table and then you mention the keyword at, and we can do it in a few different ways. I'll use offset first. So I'll say offset equal to, this is the symbol that you need to use, and provide a value in seconds. So let's say I will provide minus 60 seconds. Okay. If I run this, basically what this means is give me this, basically give me what this table had 60 seconds prior to the current time. Okay. Now what is the current time? The current time is 12:27. Okay, so 60 minutes, 60 seconds before that. So if I run this, 60 seconds before, it's still having the same like the modified data. So what I want to do is, what is my current timestamp? It is 12:27:18. This is 12:24:7. So let's say if I go 3 minutes back in time. So I'll do minus 60 into 3, so 3 minutes. If I go 3 minutes back in time, you can see that I have the original data, right? Now, this is one way of doing it. If you want to like roll back or go back 15 minutes before or 1 hour before the current time, you can use the offset. But more commonly used, I think, is the timestamp. So let's say you had some data in your database, in your table or something, on the weekend, on the Friday, and then you had some batch process that ran on the weekend. You came back on Monday and you see the data is completely screwed, right? So you want to go back to how the data looked when you left office on the Friday evening, right? So in that case, timestamp becomes very useful. So what you can do is I can just copy the same thing, and here I can say I'll provide the timestamp. Instead of at, you can also provide the before keyword. I'll just use at and say equal to and provide a timestamp. So what timestamp I want to give is, I'll just give this timestamp. Okay, so I'll just use this seconds, because at this timestamp, orders table had the original data. So I want to go back in time to this exact timestamp. Okay, now if I run it, it's actually giving me an error. That's strange, right? It's basically telling that the time travel data is not available. The requested time is either beyond the allowed time travel period or the object creation time. Okay. Now, this is actually not true, right? This error we should not be getting, because we knew at this time this table was present and it had the original data. Now, this kind of error can happen because the default time zone in your Snowflake account might be slightly different, and that might be the confusion here. So just to make sure that I'm using the local timestamp, I'll just convert this time into my local timestamp by using timestamp underscore LTZ. Okay. Now if I run it, now you can see that I'm getting the data. Okay. So this is the original data at this point in time, right? So this is basically how you can get your historical data. Now, let's say you can also use this with clone. So let's say I wanted to create a backup of this table with the original data, right? In that case, you could just say create or replace orders underscore BKP and let's say clone, right? So I'll use clone and I want orders and I'll use this same thing. So I'll just mention this, okay? And if I run this, okay, so I forgot the table keyword here. So I'll say create or replace table clone from this orders table at this timestamp. So now the clone table has been created. And if I do the select star from backup, you can see that I have the original data. Same way, I can also recreate the orders table, because if I show you the orders table, it's still having the updated data, right? So what I could do is I could recreate the table, create or replace table orders as, and I could use, basically I can use this thing, this whole query here, right? So if I run this, now my orders table would be recreated by this data, that is the historical data. that is basically having the original data. Now you can see in my orders table, I am back to my original data, right? So this is how you can use time travel. It's very useful. It kind of gives you a peace of mind that even if you screw up some data, you can still access the correct data by going back in time, right? Now, one more thing that comes as part of time travel is the undrop feature. Let's say I dropped this table. So drop table orders, okay? And now if I do a select start from orders, you see that the table does not exist. I have the possibility of undropping this table. So I can say undrop table orders. And if I run this command, you can see that the table has been successfully restored. Now, if I do a select star from orders, you can see that I have got back my table. Next feature we are going to look at is result scan. It's a feature which will let you look at the output or the result set of a previously executed query in the last 24 hours, whether it is in your session or any other session of that particular user. Okay. Now this can be very useful for debugging or certain verification purpose. For example, if you have a scenario where you executed a query now and you see that the result looks slightly different from what it was a few hours back, then using this, you could look at the data that was executed previously, right? If you know what is the query ID of the previously executed query. One of the best use case of this is, let's say if you are writing a procedure where you have some DML, DDL operations, then it will help you to kind of identify the output of those DML, DDL operations. You can return that. Okay. I'm going to show you that example in a short while, but before that, let us see how to exactly use result scan. So in order to use result scan, there are a couple of ways you could do it. One of the most commonly used is by using something called as a query ID. Okay. Now, what exactly is a query ID? In Snowflake, every time you execute a query or a command, there is this unique identifier that is tagged to every execution. Okay. So for example, if I execute this query, select star from orders, I get some data. So there are 10 orders, but on the right hand side, you see that I have something called as a query ID, right? If I copy this and if I just put it here, you can see that it's like this unique identifier. I don't know, 20-25 characters or something, right? Now, every query that you execute will have a unique query ID. Okay, so we can use this query ID within the result scan to basically use it. Okay, so for example, if I want to use the result scan, now result scan is a table function. So every table function, if you already know, you will need to use it within this table keyword, right? So here I say result scan and then I provide the query ID. So I can just provide that same query ID. And if I execute this, you see that I'm getting the same output that I got from this query. Why? Because this query had the query ID this one and I'm using that query ID here. So no matter how many times I execute, it's going to return me the same output. Now you can also generate this query ID by using an inbuilt function called as last query ID. So I can say last query ID, and this will also give me the query ID of the previously executed query. Okay, so if I run it, I'm getting this query ID, but this query ID is different from this query ID. If you look carefully, if I just copy this here, this query ID is different from this query ID. Why? Because this is returning me the previously executed query. The previously executed query is this one in line number 6, right? Now I can also go prior to the previous queries by saying -1 is basically the default, that is the last executed query. -2 would return last to last executed query and so on and so forth. Okay. Now we'll not go into all of that, but this is about query ID. Let's come back to result scan. I'm going to show you this with a proper example. So I have this history table that I have created. I think it's empty. No, it has some data. So let's truncate this history table. So truncate table orders history. Okay. And now you can see that my history table is empty and my orders table is having 10 orders. Okay. Now what I want to do is I want to always keep these two tables in sync. So for that, I have created a merge statement. Okay. Now what is this merge statement doing? This merge statement is basically trying to sync the history table always with the orders table. So I'm saying merge into the history table using the orders table. I'm joining it based on the order ID. And then I'm saying if not matched. That means if an order ID is present in the orders table but not present in the history table, then that record needs to get inserted into the history table. But if there is a match, that means that order ID is present in both the tables, then I will see if the amount is different for that order ID in these two tables. If the amount is different, then I just want to update the amount field. Okay, that is what this merge statement does. Now if I run this merge statement, it will tell me, it will give me two columns here, the number of rows inserted and the number of rows updated. Rows inserted is 10 because currently this history table was empty, so all the 10 records from orders were inserted into the history table and nothing got updated. So if I execute the history table now, you can see that I'm having all the 10 orders. Okay, now this is exactly the same as the orders table. Okay, now if I want to, so let's say I want to now know what was the output from this merge statement. Okay, in that case, I can basically run the result scan. Okay, but I will need the query ID for it. And I think after executing this merge, I also executed this statement. So I need to get the query ID -2, so that -2 would be the query that was executed not previously but previous to previous, and that was when I executed this merge statement, right? I just want to get the output of this merge statement. So now I do a select start from table of result scan. I mention the last query ID and I say -2, and now if I run this, it should give me the output of this merge statement, that is 10 and 0, right? So I've got this. Now this is just I'm doing it manually, but let's say you have a procedure. Okay, so now I have this procedure. Inside this procedure, again, I'm just doing this merge. Okay, but after doing this merge, I'm capturing the output of the merge using that same query. So table result scan of the last query ID. Okay, here I can just use last query ID because inside this procedure, just prior to this select, this merge statement got executed. So whatever the query ID that was tagged to this merge will be present in this last query ID. So by using the result scan, I will get the output of this merge statement. And then I'm fetching the two columns, because if you remember, I'm getting two columns here, number of rows inserted and number of rows updated. So two columns, I'm putting it into these two variables, insert count and update count. Okay, and that's it. And then I'm just returning whatever the insert and update count is. Okay, so now I'll execute this procedure. And the procedure is executed, and now when I call this procedure, it should always return me what is the outcome from that merge statement. So if I run this, you can see that rows inserted 0, rows updated 0. Why? Because the history and order table are now in sync, right? Let's say I do some update. So I want to update the orders table, update orders. I'll say set amount equal to 0, where order ID equal to 103. Okay, and if I update it, I think one record will get updated, right? And now in the history table, that update is not present. So ideally, when I execute this procedure, that one update should happen, right? So the update count should be 1, but insert should be 0. Let's see if I'm getting that. If I run this, you can see that rows updated is 1 and rows inserted is 0. Okay, so this is basically one of the use case of result scan. Next up is the table generator function that we have in Snowflake. This can be useful if you want to generate some dummy data or synthetic data, and let's say you want to generate millions of records instantly, then this could be pretty useful. Let's see how to use it. So it's a table function. So we say table select one from table of generator, and I just need to give a row count argument, and I say row count equal to 5. This is how you mention it, and I run it. You can see that 5 random records have been generated, right? And the value is 1 because that's what I gave here, right? Now instead of 1, let's give something more meaningful. I'll use the function seq4 or sequence4. It's basically a inbuilt function that returns values starting from 0, but it returns 4-bit integers. So I'm just going to run it now. Now you can see that it starts from 0, goes up to 4, right? So you could do it this way, or I could use the random function to generate some random numbers. So I have another column with some random numbers, or I could use another function, let's say uniform, where I can pass 3 arguments. Let's say I want to start from 1, go up to 5, and I want each number to be randomly generated, right? And if I execute this, now you can see that I have 3 columns with some values here, right? Now this is just to tell you how to use this. Now, an interesting part about this is you don't always have to just give the number of rows to generate. You could also give another argument which is called as time limit. What time limit basically means is you provide a value in seconds. So time limit 3 means it's going to execute this query for 3 seconds and it's going to return whatever data it generates in 3 seconds. You can see that it's going to execute for approximately 3 seconds. And what is the data it generated? If you think it's 2000, it's actually not 2000. If I copy this number here and put it here, you can see that it generated almost 200,000 records, right? 200,000 records was generated in 3 seconds, right? Same way, instead of 3, let's say if I put 10 seconds and if I execute this, it's going to generate much more than a few thousand records. So let's wait for 10 seconds. Let's see what happens. Very useful if you want to generate millions of records in seconds. This could be pretty useful to use. So you see that it executed exactly for 10 seconds and the number of data it generated is, let's say if I'll just put it here, 56.3 million records. So this query here returned 56 million records in 10 seconds, right? It randomly generated this data. So it could be very useful when you want to generate some data sets, right? And I'm just using these 3, but you could probably manipulate it to generate data based on whatever your requirement is. Let's try to come up with some slightly useful use case. Let's say I want to create a table where I have the top 5 data engineering skills and some course prizes for that. Okay, so let's say I am going to say case, and I'll just copy this uniform. So I'll just copy this uniform and I'll say when that uniform is equal to 1, then I want the language to be Python. Okay, and I'll just copy this 5 times. Okay, and I'll say 2 here, 3 here, 4 here, and 5 here. Let's say the second skill is SQL, then Snowflake, right? The third one, let's say we'll make it DBT, and finally Airflow. These are the 5 pretty useful skills for a data engineer, right? Now, what is this case statement doing? I could basically replace this case statement saying that I could put this here. So when uniform of this is equal to 1, then Python. When uniform of this is equal to 2, then SQL. So I can use that syntax as well, but this is kind of like a short form that you could use in Snowflake. And here I'll say end the statement and I'll call this like skills. And I will create another column, which is just going to be, let's say the price, randomly generated price. And the price could be between $10 to $50. And I'll call this like price. Okay. And I'm going to generate it from my table generator function. I'll pass in the argument, let's say row count equal to, let's say 100 records. Okay. And if I just run this, you can see that 100 randomly generated records have been populated. The skills will be randomly generated. The price is randomly generated, right? I'm just showing you how you could create synthetic data, right? So instead of row count, you could also put a time limit if you want to generate thousands or millions of records, right? So generator can be very useful if you want to generate your own synthetic data. Next up is lateral flatten. Now, this is again a special feature in Snowflake, which can be very useful if you're dealing with semi-structured data. So let's say if you have JSON data or XML data and you want to flatten that data so that you can convert this semi-structured data into row level or column level data, this is where lateral flatten becomes very useful. So I'm going to explain this with an example. I have already created a products table. It has a product ID and then there is this JSON data. The column name is raw data. Now this JSON data basically looks like this. So I just created a table. ID is an integer, raw data is a variant. So whenever you want to store JSON data or semi-structured data in Snowflake, we use this column data type called as variant. And I have inserted 3 records into it. So 3 JSON data into this. Let's start by writing a query where I'm going to extract this name, price, coup or colors, etc. Okay. So what I just need to do is I can say there is the ID and my JSON column name is raw data. And I want to extract, let's say SKU, which is basically the product code. I also want to extract the name, that is, let's say I'll call it like prod name. Okay. And I also want to extract, let's say, the color of these laptops. So if I run this, you can see that I'm able to get it, right? So from JSON file, I'm able to get all of this data here. The only thing is these were directly available in individual fields, right? what happens to these fields? Like in colors, I have a list of different values. In specs, I have like a key value pair. In variant column, I have again nested dictionaries, right? So we'll see how to extract all of that. Let's start with this extracting each individual list values from colors. Okay. So in order to do that, this is where lateral flatten comes in. So what I need to do is I need to join and say lateral flatten, and inside flatten I need to provide an input. The input is basically kind of like the path to your JSON from where this flattening needs to happen, right? Now I know that it's raw data and it's colors. This is basically what I want to flatten, because I want to flatten this one, right? These multiple elements in my list here, I want to flatten it into separate rows, right? So I provide that path here in the input, and let's say give an alias for this table called as LF, and here I will say LF dot index, because it's an index. So index will have an, because it's a list, so list will have an index, and list will also have a value. So we'll pass in that. Okay. And now if I run it, now we can see that from ID had one row, now ID has 3 rows, because we did the flattening based on colors. This color had, for this particular ID, this color field had 3 values, right? Red, blue, and black. So these are now scattered across 3 different rows, right? Now, the value here is not a string value. It's basically a JSON value. If you want to get the string value, then you need to explicitly convert it into string. So if I run this now this is basically a string. Okay. Now, if you look carefully, I'm only getting 2 products here, 1 and 2. But if I look into my products table, I had actually 3 products. So the third product is missing because it does not have any color attribute here. The color is basically empty for this, right? So if you look at here, for the ID 3, colors is empty. There is no colors. That is why it does not show up in this lateral flatten. So if you want that also to show up, basically you want to return, even if when the flattening happens, if there is no value in that particular attribute, if you want that to still show up, then you kind of need to do something like an outer join. And here you could specify that by using this argument called outer, and you just make it true. So it will behave like an outer join. Now if I run it, even the product 3 shows up, but basically the values are null, right? So this is basically how I can extract values from within a list in your JSON. But now let's look at how do I extract this key value pairs. The specs field here is a key value pair. CPU i7, RAM is 16, etc, etc, right? In order to do that, I will just copy this same query. I will put it here, and now I should basically not be looking for colors, but I am looking for specs, because I'm trying to flatten this part of my JSON, right? So I mentioned that in my flatten. I don't need this outer because specs is present for every field. I don't need this colors. I'll remove that. And since it's a key value pair, I do not have an index. Index is only present when there is a list or an array, right? For a key value pair, you will basically have a key and a value. So if I just run this, now you can see that for the product laptop, and let's say product is a string, so I'll convert this into a string just so it looks better. And now you can see that, and I don't need this Q, so let me remove this just to have minimum data here. If I run it now, for product ID 1, which is a laptop, I have the key, that is CPU, RAM, and SSD, and its values are present here, right? So this is how I was able to flatten the key value pair within my JSON. Finally, let's also see how would you flatten this nested JSON data that is present here, right? Now, in order to do that, I'll again copy this whole thing and I will put it here. And now, you know, instead of specs, I should basically mention this attribute, this field, that is variants, right? And once I mention that, inside this is basically a list, right? And you know that once it's a list, you will get the index and the value. So here I will now pass index and I will pass the value, right? But now that value is not a string, but that value is basically again like a sub dictionary, right? So I do not want to convert that to string. Let it stay as it is. If I run this, you can see that I'm getting some value, but inside this value here, again, this is kind of like a sub dictionary, right? So again, we need to flatten this now, but here I can see I have 3 different attributes here. There is a color, there is a stock, and there is an extra, right? If you see here, there is color, stock and extra, that is part of each of these dictionaries, sub dictionaries here, right? So I can extract each of them separately. So from value, I can fetch the color, right? And I will copy this, I'll put it twice. So I'll fetch the stock and I'll fetch the extras, okay? And if I just run this, now we can see that, okay, extras, I'm getting it as null. Ideally, it should not be null, right? Okay, I think there's a typo, extras. So if I run this, now you can see that I was able to flatten the color and the stock that is inside this variance. But now when it comes to extras, extras is again kind of like a list, right? So I need to flatten this as well. And that is where I will now need to put this into a subquery. So for that, I'll say with CTE as, I'll move this to the right. I'll open the parenthesis here. I'll close the parenthesis here. I'll say select star from CTE. And what I want to do is, if I run this, I'll still get the same output, but I want to again flatten this particular field. Let's give a name for this. I'll just call it like more, okay? And I'll say join lateral flatten, and I'll say input. This time the input is going to be, I think it's going to be this one, right? So it should be CTE dot more, right? And I'll call this like F. And here I want to fetch, let's say, the ID and the prod name, or I'll just say everything. So CTE dot star. And then I just want to say F dot, it's basically a list. So I will say index, or I do not want the index. I'll just fetch the value now. Okay. And I'll convert this into a string. So if I now run this whole thing, and I'm getting an error because I forgot the equal to operator here. Let me run this again now. And now you can see that I'm getting the value, but this value is returned as null. So I think I screwed up something. Let's see what it is. And that is, I missed the colon here. So now let me run this. And now you can see that I have got the value. So I was able to flatten this sub list into individual values, right? So once you have these individual values which are put into a row or a column, then you can use this like your table and then do whatever analysis you want, right? So this is how you could kind of unstructure your semi-structured data using lateral flatten in Snowflake. The final feature that we are going to look at is called split to table. It's a simple one. Now, the alternative to this is present in SQL Server and Postgres, but Snowflake also has it and it's pretty useful. Now, what this function basically does is it's a table function. So if you have a string, it will allow you to split your string into multiple rows based on certain delimiter. Now, let's take a simple example for that. Let's say I have a string, like some comma separated string, okay? So let's say select star from table, because it's a table function. So generally we enclose it within this table keyword. And then I say the split to table function. And then I need to pass two arguments. The first one is the string itself and the second is the delimiter. In this case, delimiter, let's say we'll keep it comma, or let's say we'll keep it semicolon. And then I have the three text, let's say X semicolon Y semicolon Z. And if I run this, you can see that I'm getting three columns. It's a sequence, index, and value. The value is basically the value that was mentioned here, right? But since the delimiter is semicolon, it has split that string because there were three different values into three different rows here, right? And by default, Snowflake will provide you the sequence number and the index, okay? If you only want the value, you can just tell the value and you'll only get the value to be returned. Now let me explain a very common use case for this. I have this table called employee skills. It's a table which has data about 10 employees, their name, the department they belong to, and the skills they have. And you can see the skills are comma separated values. For data engineering, there is SQL, Python, DBT, Airflow. There's another person, Carol. In analytics, she has skills like SQL, Python, and Power BI, and so on and so forth, right? Now, when you do some analysis or certain activities, you would ideally want these comma separated values to be in separate rows, right? Which could help you with your future analysis. So if I have to convert these skills to be portrayed into separate rows, that is where this split to table can be pretty useful. So in order to do that, what I am going to do is I'll just copy this again here. And I will give an alias for this like E, but if I have to, so basically I need to use this, right? And I need to use this, I need to pass the skills as the first argument. Now, in order to do that, I cannot join directly with this table, right? Because there is no join condition. So that's where I can use something called as a lateral. Okay, so I'll say lateral. This is something that we saw in the previous feature as well. I'll explain you what lateral is right now. Okay, I say lateral and then I say split to table, and then I provide e dot that field, that is skills, and my delimiter in this case is comma, right? And I'll give a name, I'll give an alias for this, like let's say yes. Okay, and here I'll say yes dot value. Okay, now if I execute this, let's execute this and see what happens. You can see that I'm getting now 26 rows, and if you just look for the employee one, that is Alice, she had 4 skills: SQL, Python, DBT, Airflow. But now in the last column, you can see that SQL, Python, DBT, Airflow are split into 4 separate rows, right? And the same thing happens for every other employee, right? Now, what is split to table? You understand, it's basically splitting every value within that enclosed delimiter into separate rows. But why do you need a lateral here? And the same thing we used lateral when we were talking about flatten as well. The reason why you need lateral, basically what lateral does is, in this part of the query, I am using a column from my about table, right? If I did not have lateral, SQL will not allow me to use this. Okay, lateral is basically used kind of like, generally use it when you have a subquery here and you want to use a field from a table that is coming prior to this subquery, then you will need to use lateral. Here there is no subquery, but then these table functions can be utilized for that. Okay, so that's the purpose of using lateral. Just because I want to use this skills column from the about table in this part of the query, I need to use lateral. Okay, the second thing is, I told you split to table is a table function. So generally every table function should be enclosed within the table keyword, but I'm not using the table keyword here. In fact, if I use the table keyword, it's going to throw me an error. The reason for that is, in Snowflake, if I am using lateral and then I'm using a table function, I don't need to specify the table keyword. Okay, that is not required in Snowflake. That's why this works like this. So I think that's all. This is all about split to table. It's pretty simple, but very, very handy in many, many cases. I hope you liked this video and you found it useful. Let me know in the comments below what is your favorite feature of Snowflake. One more thing, definitely check out SQLNest. The beta launch is happening in the next few days on 16th of November. You will find all the details in the video description. Thank you so much for watching and I'll see you soon in the next one. Bye.